And we're live. We're live on Wednesday again. Another fireside episode. I don't think we need shades today. I think we have shade. We have shade from the trees. Yeah, we're fine. We can see the screen. Let's see if we have anybody. Do we have anybody? Oh, we have two people. Testing, testing. Testing. You know, I just want to start out by giving shout outs. You guys have been great the past couple of weeks with answering questions. Now, I think first period I had Ayana and Jayana. I think I had some from Ross. I have not heard anything from Faith or Courtney. Definitely not anything from Logan or Justin. I don't think Logan or Justin have done anything school related. Let's see. Robert, Kayla. Kayla's always answering questions. She's answered a lot. Justin Scarberry, definitely. Caleb, absolutely. That's about it for first period. Who is King Daka, by the way? King Daka, type again who you are, because I just don't know. Third period. Let's see. We used to hear stuff from Riley. We don't anymore. Louise is always answering questions. He got extra hundreds. Margaret's even answered some. Ivy did. Anthony did. Yep. Janaya did. And Jasmine's Rubinos. And Amari. Amari's answered a lot. Gabe. That's right, Gabe. And then I also saw last week, I saw Robert Barlow and Anaya B. And Chanel. Chanel's always there. Jessica Fletcher, even. Jasmine Hicks. Cody. Some James Mann. Nope, didn't see Christopher Miller. No Jordan. No Nathan. Well, no, that's not true. Nathan. Scott Produce definitely answered questions. The rest of Gabe, of course, Gabe. Gabe's always there. The rest of these folks have just disappeared off the globe. I don't know, man. Jeez, I wonder what happened to them. If you guys would text your classmates and tell them, here's the deal. We're going to do like extra credit opportunities and extra grade opportunities all the way till the end of May, and then everything's going to stop at the end of May. I have upped the points in the grade book. So if you answer questions on here, or rather in Google Classroom, not only is it worth a class grade now, it's been boosted up to a quiz grade. So you can get 100 quiz grade for answering questions on Google Classroom. Hector! Taco Wednesday, see? See? Taco Wednesday. Hi, Nelly No. Dante is here. Gabe is here. I gotta have 5 people before I can start the next problem. But that's great, though. Buenos dias, Hector. Buenos dias. Buenas tardes. So with the warming of the weather and with the increasing of the humidity, you should see the transmission rates drop, but that doesn't mean the non-existence of the virus. What that means is the transmission rate will decrease. But keep in mind that that does not mean the ratification of the virus. The virus is still there. It's just not as transmittable in warm, humid environments. When those warm, humid environments change, they go back to cold and dry, then the transmission rate goes way up. So I don't know what models you guys are looking at. During the summertime, things should progress almost back to normal, but then as the season changes, it will be seasonal. Anybody else? Oh, we got 5 people here. Yay. Okay. So here is what's going on today. Have any of you ever wondered how chemical formulas were invented? Like, who decided that carbon dioxide was CO2? Did human beings make that up just out of thin air? Like, oh yeah, carbon dioxide, CO2. Did somebody, hey, Margaret, did somebody just decide that salt was NaCl just one day? NaCl. Yeah, salt. Water. Oh, that's going to be, let's call that H2O. Sounds good. Yep, H2O. Did somebody just decide that one day? No. But you see, all your life, guys, all your life, you just know chemical formulas because somebody told it to you. But human beings haven't always known what chemical formulas are. They didn't always exist. In fact, prior to the 19th century, they didn't. It wasn't for somebody named John Dalton, which was one of your people that you guys studied about. Okay. So chemical formulas were actually invented by math. So that's what I'm going to show you today. And you're going to think, oh my God, this is the most complicated thing I've ever seen in my life. And then you're going to go, oh, that's not too bad. So I'm going to teach you how to do a chemical formula. And I'm going to teach you how to calculate a chemical formula. Basically any chemical formula. Okay? Yep. Did not. Good. All righty. So here's how you do it. Okay. Let's say, for example, I had a jar of something. And in that jar, I knew that there was copper and there was chlorine. And I knew that 47%, just from weighing the stuff, okay, doing a chemical reaction, weighing the stuff, I knew that 47% of it was copper. And I knew that from doing a chemical reaction and balancing it and doing stoichiometry, which you guys did a couple weeks ago, that 53% of that stuff in the jar was chlorine, just by getting the masses. So if I knew that 47% of stuff was copper, and I knew that 53% of it was chlorine, I can find out what the chemical formula is going to be. So today I'm going to teach you how to do an organized way of figuring out any chemical formula. All right. If you know what percentage of the whole mass you have, you can figure out any chemical formula. Watch this. You just need a pencil, a paper, a calculator, and periodic table, period. Here we go. All right, write this down. 47% copper, 53% chloride. Okay? 47% copper, 53% chloride. Here's what you do. You make yourself a nice organizational table like this. Okay? Make yourself a nice organizational table. Again, what are we doing? We're figuring out what the chemical formula is going to be. Any chemical formula. This is how you do it. Okay? Make yourself a nice organizational data table. 47% copper, 53% chlorine. Now, okay, percentages. Well, what are we going to do with those? We are going to pretend that 47% means you have 47 grams of copper. Well, why would you do that? Well, pretend you have 100 grams of this stuff. Well, what's 47% of 100 grams? 47 grams. Okay. 53% of 100 grams is 53 grams of chlorine. Not done yet. Okay, so now you have 47 grams of copper, 53 grams of chlorine. So now, go get your calculator. Okay, unlock your screen so you can do this. And get your old periodic table. And what we're going to do now is we're going to figure out how many moles if you remember what moles are. There are 47 grams of copper. So we're going to go to the periodic table. We're going to look up the mass of copper. Okay, and the mass of copper right here is 63.55. So we're going to take 63.55, and we're going to divide 47 by 63.55 grams. And we're going to take the mass of chlorine right here, which is 35.45. And we're going to divide that. So right here, this is from the periodic table. This is grams of copper. And down here, 35.45, that's grams of chlorine. Okay? So we're going to divide and we're going to divide. 47 divided by 63.55. That gives you 0.739. Okay? Down here, 53 divided by 35.4. 53 divided by 35.4. 53 divided by 35.4. That gives you 1.49. Okay, so now you guys are confused. You'd be like, well, you can't have a chemical formula that says Cu 0.739, chlorine 1.49. No, you cannot. No, those are not proper chemical formulas. So we're going to do a trick at the very end here. We're going to get rid of all these decimals. We're going to divide by the lowest common denominator. We're going to divide by the smallest number to turn these things into whole numbers. Watch this. If you divide 0.739 by 0.739, you'll get 1. And if you divide 1.49 by 0.739, you'll get approximately 2. So now your answer is Cu1 Cl2. There is your final answer. Your formula for coppers and chlorines is CuCl2. And oh my goodness, we just happen to have some right here. Copper chloride, CuCl2. So that's how chemical formulas were invented. Scientists did experiments. They did chemical reactions, right? And they weighed out how much stuff they got. And they calculated the percentages of each element that they had based on the weight. And then they took the percentages and they turned them into grams, and they used the periodic table, and they got these decimal numbers. And they said, well, you can't have decimal numbers of atoms. No, you can't. So they did some math. They said, how are we going to turn these decimal numbers into whole numbers? No, you just divide by the lowest number. You get whole numbers. Actual real chemical formulas. Okay? And that's how they were invented. By doing math. There's the secret. That is how carbon dioxide was invented. That's how H2O was invented. That's how NaCl was invented. Table salt. That's how all these chemical formulas were invented, by doing math. Basically, high school algebra. Yep. John Dalton. Early scientists. All right. So those are the types of problems that we have this week. Now, there's one more step to this. One more step. Light work. Margaret. Light work, huh? Well, that's good. I thought you guys were going to think it was impossible and super hard. All right. So here's one extra step. Suppose you do all that math, right? But then you find out from doing all that work that the actual mass of your compound is a little bit different. So let's say you find your empirical your formula, right, to be CH3O. let's say you did all the math and you find out, okay, this is my guess. This is what I think the formula is, CH3O. That would be your best guess. That's called an empirical formula. An empirical formula is a best guess. That's what we just did. Okay, so we just did this. We did, okay, this is the best guess mathematically of what the formula is. But this was the days before computers and fancy equipment. That's how John Dalton did it, the OGs. Nowadays, we have fancy equipment. We have GC mass specs, we have chromatography, we have nuclear magnetic resonance imaging, we have all kinds of things. So let's say you did some math and you found, yep, the formula is CH3O. Okay? But the real answer is a bit different. Suppose you go use fancy equipment and you go to a lab and they say, okay, that's a good guess, but the molecular formula, it's a bit different. Here's why. If you added up all the masses on the periodic table of this one, okay, the mass would say it's 31 grams per mole. So that's carbon plus 3 hydrogens plus oxygens. You would have 31 grams per mole. But in actuality, it's supposed to be 62 grams per mole. Okay, so on your math tells you that this is right, but in reality, it's actually 62 grams per mole. Did I do everything wrong? Actually, no. Okay, this is what you do. How many times bigger is 31 than 62? Let's see. If I divide 62 by 31, what is that? Oh, that's 2. So that means my real formula is actually twice as big as my empirical formula. Twice as big. So here's all you have to do. You take that and you multiply it, everything, all the atoms by 2. And you get C2H6O2. And the real answer is C2H6O2. All right, again, the empirical formula is what you do when you do this chart. That's your best guess. Paper's blowing everywhere. That's an empirical formula. That means you just use the periodic table and you divide it. Okay, so in the real world, okay, that's called a molecular formula. So an empirical formula is your best estimation. The molecular formula is what it really and truly is. Now, why would there be a difference? Well, because back when they used to do empirical formulas, they didn't have all the fancy equipment and computers that we have today. So with all the fancy equipment and computers, we're able to know molecular formulas. So all you do is you figure out how much bigger the molecular formula is. Well, in this case, it happens to be twice as big. And so all you do is you just double this formula. Okay? That's how scientists are able to figure out chemical formulas. Bang, period. Right, Margaret, 2. Exactly. Exactly. Okay? Now, I'm about to show you the easiest thing in the world. No thought required. If I had a real formula, okay, if my molecular formula was C6H12O6, what would be my empirical formula? All right, real quick in the comments, let's see if you guys can figure this out. If your actual molecular formula was C6H12O6, what would my empirical formula be if you were to simplify it all the way down? Take a guess. Type your guesses. What do you think the empirical formula is? The guess. Here's the real formula. What's the simplified version of it? Simplify that formula down. Type it in the comments. What do you think? Anybody? Nobody? Well, you must have gone to sleep. Okay, here's all you got to do. If you notice, everything is divisible by 6, right? So you divide by a common denominator and you simplify everything down. So your empirical formula is CH2O. Okay? So an empirical formula is the simplified version of a molecular formula. Oh, close. Close, Dante. You see, you have C3H6O3. You can actually divide those by 3 and simplify it all the way down. Okay, one more. All right, if your molecular formula is N2O4, what's my empirical formula? I can't spell. Okay, so how do you simplify down N2O4? What would be the empirical formula of N2O4? Type it in the get. Oh, nice. That's right. That's right, King Dakar. Anybody else? Margaret? Marcus? Dante? Thank goodness for King Dakar. He's the only one that answers me. Margaret, any guesses? Simplify it down. Nelly, very good. NO2, yes is the answer. So you divide both of these by 2. You just divide it by a common denominator and you get NO2. That's it. That's it. So to review, okay, because I'll keep today's session short. We'll get back into doing more reactions later, but right now we're just focusing on making formulas. So this simple version was called the empirical formula. And this is how chemical formulas were invented in the first place back in the day. So empirical formulas, they started with mass percentages. They divided by the periodic table. You get rid of the decimals by dividing by the smallest number. So you get an empirical formula. That's the simplest guess. Okay. Then what they did was later in time, as things got more sophisticated, they found out, oh, molecular formulas are a bit more complicated. They're bigger. Well, how much bigger? Well, you just divide the masses to find out how much bigger. Okay? Most likely, most of the time, you'll get the molecular formula because we have all this fancy modern stuff and we can do in science today. But what would be the empirical formula? This is just showing you that empirical formula is a simplified down version of a molecular formula. That's all. Okay, so today in the Google Classroom, you guys will have problems like this and problems like this. Period. There'll probably be about 4 questions as usual. So I'll post that in a Google question along with this video and the PowerPoints. So that'll be this week's assignment. I am going to make this worth a quiz grade. So it will boost some grades maybe. So that'll be in the Google Classroom. I will also post a Zoom link starting at 3 if anyone wants to walk through the problems. But other than that, very good job. Period. Period, everybody. Like, comment, subscribe, ring the bell, text your friends. Let them know that we still have chemistry on Wednesdays and Thursdays. Thank you for your guys' time. Thank you for period. Yes, Nelly. Thank you. Now we can end the session. period.